Before we get started with today's notes, are there any questions on any of the assignments so far? Any questions over any of the homework assignments? What we're looking at today is very similar to what we did yesterday and the day before. There's just a few more steps to it. We're going to be using the same steps, but we'll have to do them twice. We'll have to go through them twice to be able to fully solve this. Now, there are some like this here. There was one like this on the note sheet yesterday, but the way that the variables and how it worked out a little bit different. I want us to look at this here so we've at least seen it once, see how this works, and see that this is not actually too more complicated or any more difficult than what we did before and what we've done. Now, whenever we solve these here, again, we want the variables, we want the radical by itself, and if we can't get it by itself, because here we've got 2, we want to even them out as best we can. So here they are evened out. So this time we can put both to the second power. Because if we square both sides, we are going to reduce some of the radicals. On the left-hand side, the square root of 2x squared, well, nicely enough, these will cancel out, telling us that this is 2x. Now, the other side, we can't just cancel them out because we have two things being multiplied there. So really what we're saying is that I have the square root of x plus 7 minus 1 times the square root of x plus 7 minus 1. We're just going to have to use our distributive property and multiply this through. So when we use our distributive property, the first thing we're going to do is multiply the square root of x plus 7 times square root of x plus 7. Which realistically is just saying that we have the square root of x plus 7 squared. It's being multiplied by itself. Because we could rewrite it in this way here, square root of x plus 7 squared, or we can say the square root of x plus 7 in parentheses squared. But either way, the square root and square are going to simplify out. Now our next one's going to be the square root of x plus 7 times negative 1, which is negative square root of x plus 7. Then we move over to the negative 1 and multiply it through. Well, negative 1 times square root of x plus 7 is negative square root x plus 7. And last but not least, negative 1 times negative 1 is plus 1. Any questions on this so far? Well, we still have the 2x. Here, the square root and square will cancel, telling us that we have x plus 7. Well, plus 1, because we do still have that 1 there. If we wanted to, at this point, we could have really written this as x plus 8. We could add those two together. But we do have two like terms. Negative square root of x plus 7 minus square root of x plus 7, which would give us what? Negative 2 square root of x plus 7. So doing this here, did we simplify some of the radicals out? Well, yes. Do I still have a radical left? Yes. So realistically, the steps that we worked through the first one of getting the radicals by themselves or getting them evened out. 2, we put both sides to the nth power, and then we really started on the solving step, but we still have a radical left, yes? So we just go back to step 1, get the radical by itself. Now, most of the ones in the book, when we get the radical by itself, and the one that we had yesterday that looked like this, doing this next step, all the variables would have canceled out, and we would have just got a number. That's where this one's different, because if we look at this here, I have an x on one side, I have 2x on the other. So even if I subtract x from both sides, we're still going to have a variable that we'll have to work with. Now at this point here, we can go on and start trying to move things, or, well, we still need to add the 7 and 1. If you've already added it, that's perfectly fine. I'm going to go on and just rewrite it with plus 8. Now at this point here, we've got to get the radical by itself. So what can we do first? We can subtract x, yes. And this would tell us that x is equal to 8 minus 2 square root of x plus 7. Well, now we're going to need to subtract the 8. X minus 8 is equal to negative 2 square root of x plus 7. Is the radical by itself? No. What do we got to do? We have to divide both sides by negative 2. Which will tell us that we have x minus 8 divided by negative 2 is equal to the square root of x plus 7. We can leave it as negative 2 in the denominator. We can move the negative to the numerator if we wanted to. Either way is still going to give us the same thing. And there is a trick we can use with that negative 2 that we'll do in a minute. But are there any questions on this so far? Has this made it any real difficult, more difficult than yesterday? No. Although you probably wouldn't have thought at the beginning of this year that you would have thought that all these steps aren't that bad. Yes. So this has started to become a little bit easier. You're getting more used to working with this. Now what would we do at this point? We would square both sides, yes? So we're going to square this side and we're going to square this side. And luckily over here, square root and square will cancel, telling us that we have x plus 7. All the radicals are gone now. It just took a few more steps to get there. On the other side, well, we're saying that we have x minus 8 over negative 2 times x minus 8 over negative 2. X plus 7. Multiplying these two rational expressions, it's going to be easier to multiply the denominators first, because we have negative 2 times negative 2. Which gives us 4. Now we're also going to multiply the numerator, so we're going to multiply x minus 8 by x minus 8. Well, our x times x would give us x squared. X times negative 8 would be negative 8x. Negative 8 times x is negative 8x. And negative 8 times negative 8 is plus 64. Yep, and that's going to pop it right there. Well, let's go on and combine like terms so it's a little bit easier to look at. X squared minus 16x plus 64 over 4 is equal to x plus 7. Any questions on any of this here so far? Now at this point, throughout all the math classes you've taken, you've dealt with equations that had fractions or decimals in there, yes? And for the most part, whenever we hit that, it was more, okay, we've got to deal with fractions and decimals and work through it, yes? There is something nice that we call a scalar. And I've talked about scalars before when we looked at graphing functions, where we talked about a vertical stretch or shrink was multiplying a function by a scalar, yes? And what's interestingly enough, and going to use the graphing calculator to show this, is if we look at this function, y equals enter, because we have x squared minus 16x plus 64 all over 4, because that's our function, yes? Now, if I'd have multiplied the whole thing by 4, well, that just means the 4 in the denominator is going to cancel out. It's going to go away, which will just leave us with the equation x squared minus 16x plus 64, yes? Now, I will tell you that it's going to change how the quadratic equation looks. It's going to make it look different. But our main focus for either one of these here in solving is to find out where it crosses the x-axis. What value of x is going to make this function equal 0, yes? So let's see what happens to the x-axis. I'll have to change the scale most likely. Yep. Zoom 6. A little better. But we see it comes down and crosses right there. And the other one does the exact same thing, yes? Let's say zoom. I don't like using fit, but we'll tell it zoom fit. But it does something like this here. Let's go back to standard. Because this here has the same x-intercept. It's going to cross at the same spot. And it's kind of hard to see with this one here. But if we said, this is going to give us the same thing. That was negative 16, 4, and 20. No, let's see here. What would be nice? 20 is 2 and 10. If I give it 12. Giving us another function. And if we graph this here, we see that it does cross those 2 points. But the other function also crosses at those 2 points. Second table. Go down to the positives. Well, if we look at the x value at 2, the y values are still both 0, yes? So it's still crossing at the same spot. Now, when x is 3, we have different values. When x is 4, different. 5, 6, 8. But then at 10, it's still at 0, 0, yes? So using this multiplication of 4, the scalar, change the y values at every single point except where it crossed the x-axis, yes? Those solutions. So using this scalar is nice if we are solving. Because what that tells me I can do with this, just stick with blue, is that if I multiply this side by 4 and this side by 4, we're changing how it looks. We're changing all of the points except for the solutions for this here. Because, nicely enough, those will go away, telling me that I have x squared minus 16x plus 64. But it's not equal to x plus 7 anymore. I've got to multiply the other side by 4, which would tell us that we have 4x plus. But do we have any fractions anymore? No. And that's what's nice with scalars. So even if I had a decimal values, decimals throughout all of them, we can multiply it by some unit of 10 to move the decimals over so that all the decimals are gone. Now it's easier to work with. Last but not least, since we do have a quadratic, we need this thing equal to 0. So we can subtract 4x from both sides. I have a feeling that some of y'all are running out of paper. Yes? Yeah, let's go and subtract the 28. It's a little bit nicer here to do both, unlike earlier when we just had 2x. Kind of would be squished trying to get the 2x and 8 all in the same spot. What that tells us is that we have x squared minus 20x plus 36 is equal to 0. We can go and factor this or graph it. Either way will work. Do you all want to factor or graph? We can do both. If we graph, I'll have to clear some stuff out. Clear that out. No, clear that out. Because we have x squared minus 20x plus 36. So we do have one place that it crosses, yes? But with any quadratic, it's degree 2, we should have 2 solutions, yes? Second graph. So I do see one of them is at 2, yes? We know a quadratic function is a U-shaped graph. So if it comes down and crosses, it's going to have to come back up, yes? So most likely, is the other solution going to be x value bigger or smaller than 2? Bigger, because if we came down for the y values, 36, 17, 0, negative, I'm going to have to come back up, which means these negatives are eventually going to have to turn positive if I go down. Yep, it's going to be 18. So 18 is the other value. Now if we graph this, or not graph this, factored it, since 36 is positive, our signs would be the same. Factors of x squared would be x and x, and well, 2 and 18. Set both of those equal to 0 and solve, saying that x minus 2 is 0. X minus 18 is equal to 0. Here we would add 2, saying x is equal to 2. Add 18, saying x is equal to 18. And as we've seen so far, since they're both positive, most likely both are going to work, yes? But it's good to go on and check. Any questions before we check these here? X equal 2, comma, 18. So with 2, we can say the square root of 2 times 2 is equal to the square root of 2 plus 7 minus 1. Well, 2 times 2 is 4. Square root of 4 is 2. 2 plus 7 is 9. Square root of 9 is 3. And 3 minus 1 is 2. So that does work. Let's try 18. So 2 times 18 is equal to the square root of 18 plus 7 minus 1. Well, again, if y'all are working this out, especially on the homework, most likely you would have plugged this in. Square root of 2 times 18 and gotten 6, because 2 times 18 is 36. Square root of 36 is 6. On the other side, 18 plus 7 is 25. And the square root of 25 is 5. 5 minus 1 gives us 4. Well, those aren't equal. So this time here, x is equal to 2. So that's a little bit different. We haven't had a case where a positive number didn't work, but it is possible for a positive number to be an extraneous solution. But that's it. That's all we have to do for this here. Now, most likely, you're not going to see one of these on the ACT. I don't see these coming up on the ACT. If they do, it's going to be easier if I hit Control Z than trying to do that. And some of the ones that we have like this here, let's get a highlighter. This step right here, especially in the book, would have given us 0. They would have subtracted out completely, which would have made it a little bit easier, because if they did simplify out, we would have got -8 is equal to -2 square root x plus 7 divided by -2. That's a little bit easier to work with, because now we're just squaring. We don't have a quadratic we would deal with. It works a little bit easier. But this here is not any really harder. It's just a few more steps. We're having to work and manipulate the numbers a little more, but that's about it. Questions on this here?